Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the last question of JEE Advanced 2014 Physics Paper 2 Code 8. So let us solve question number 40. Students, let us solve the last question of 2014 paper. A person is in a lift. A person in a lift is holding a water jar. This is a jar which contains water. And this person is in a lift and has a hole which has a hole at the lower end of its side. Lower end of its side. So somewhere here or lower end or somewhere here, there is a hole. When the lift is at rest, the water jet comes out of the hole, hits the floor of the lift. So this comes out of this and hits the floor of the lift. Like that. Of the lift at a distance of 1.2 meter from the person. So this distance is 1.2 meter. So it is at a distance of 1.2 meter from the person. In the following state of the lift's motion, so there is a list 1 which says the lift is accelerating vertically upward with acceleration say A, accelerating downward with acceleration A, less than that of gravity. So this A is less than G. But it is accelerating up, accelerating down. Third case is lift is moving vertically with constant speed. This is the third case. Acceleration is 0. And the fourth one, lift is falling freely. Fourth one is falling freely. A equals to Z vertical downward. This is P, this is Q, this is R, this is S. These are the four possible options, and we'll match what will happen. And the distance where the water jet hits the floor is given in the list. So this is the D value where the water will hit 1.2 meter as given in the motion. Which one will match with whom, that we have to find out. Now the thing is that we have to find if the lift is accelerating up, first case, then due to, if I use this inertial frame, non-inertial frame of reference, from the frame of this lift, the G effective equals to G plus A, that is, it will increase. So G effective is greater than G. So for option number P, G effective is greater than G. And what about the liquid that comes out of the container where it hits? The formula is that, suppose this height is H1 and this height is H2. H1 is the height from the surface to the hole, and H2 is the hole and the bottom of the vessel. If this moves out with velocity, obviously we know from velocity of efflux, this is 2g h1, this is the velocity over here. The vertical velocity component will be 0, and the time it will take to reach this is equal to that height is given, initial velocity 0, this is half gt square. So it is t equals to 2h2 by g under root. this formula I have to use. This distance d equals to this velocity 2g h1 root and this time 2h2 divided by g. If I solve this, g will cancel out. This is 4 h1 h2 under root. This is the distance formula. In the first case, that the lift is accelerating upward, g effective will be more than g, but this d is independent of g. As you can see here, finally it is cutting out. So this will be the answer. And as initially when it is at rest and it is falling at a distance of 1.2 meter, now also it will be at a distance of 1.2 meter because it is independent of g. So in this case, p, the distance d will be 1.2 meter because this expression doesn't contain g, cancels out. So whether it is accelerating up or down, it doesn't matter. In the option Q, so this P is the answer is this one. If I see this one Q, the lift is accelerating downward, then what will the answer? Then in that case G effective will be less than G, but again it is independent of G, so answer D will be 1.2 meter. So for that wave again this is the answer. Option 4, the lift is moving vertically up with constant speed. If lift is moving with constant speed, that is option number S, then the G effective becomes equals to G. Then also this will cancel out and D equals to 1.2 meter. So that is also for this option 1, for this option 1, for this option 1. So for R also option 1. That means PQR option number 1. P1 Q1 R1. This is not true. This is not true. This is not true. So this is the answer. Again, we'll see the lift is falling vertically freely. What will happen? This also will check, but the answer is 3. The lift is falling vertically downward. What will happen? Now, we know that in this situation, this is the lift and this is the water in the container. If this lift falls down vertical downward, that means acceleration equals to G. Acceleration of the lift is equal to acceleration D. Then the acceleration of this one, G effective, will be, because this is experiencing G downward, and also because this system is non-inertial frame and moving downward with G, so we have to apply pseudo force in this direction with acceleration G, so G effective becomes 0. Now G effective is 0 because we know that D equals to 4 of H1 H2 this, but that we got from the expression, that this expression 2GH1 and under root of 2H2 by G. This is the expression. If I put this G effective was 0, then D comes out to be 0. D comes out to be 0 because this value has to put. In this case 0 by 0 you cannot put here. This will be 0. This has to be 0. The water will not come out. No water leaks out of the jar. This is S is 4. So this one is correct answer. Why water is the, so this is the, for this question option number 3 is the right answer. Now why the water did not come out? Because the left acceleration in the downward direction, and that is equal to the acceleration due to gravity, and this is under in free fall condition, so all the system will fall down with equal acceleration. So therefore the water will not leak because the G effective becomes 0 in that frame of reference. Okay, so this is all we have in your 2014 JEE Advanced Physics paper. I hope you understand this. Thank you.